Hey there! Today I will talk about BentoML, which is a tool that I have used many times in many different projects, and I find it super cool. So what exactly is it? Well, I'm on the official website, and this is the official description. BentoML is the platform for software engineers to build AI products, which is super vague. But if we go to the documentation, I think there's a better description over here. Which says that BentoML is a framework for building reliable, scalable, and cost-efficient AI applications. It comes with everything you need for model serving, application packaging, and production deployment, right? And that's, in my opinion, a nice summary of what the tool does. However, I am not going to go through the docs from now on, and instead I prepared a small sketch that in my opinion, captures really nicely what Bento is about. So if you're a machine learning engineer, right, you know that there are a bunch of different frameworks to do machine learning and deep learning, right? Things like transformers, PyTorch, blah, 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 and so on. And the problem is that if you want to, let's say, Dockerize a model that was trained in one of these frameworks, right, and deploy it on, I don't know, specific service like AWS Lambda, you need to write very custom logic, right? And the chances are, if you go from, let's say, transformers to Lambda, the code that you are going to write is not going to be transferable to another use case where you want to take the same model, but let's say put it on a SageMaker, right? This is where Bento comes in, and this is like what Bento tries to solve. So BentoML actually decided to create this unified data format, right? That can be used for any framework. So you have a checkpoint of a model, right? And you want to convert it to a bento. And then you can easily deploy it on any, let's say, platform, whether it's just like containerizing it and putting it on your Kubernetes cluster, or whether it's things like AWS Lambda and so on and so on. Everything is standardized and everything is taken care of. What I want to point out is that there are actually two Python packages under the hood. One of them is BentoML, and it's focused on the first part, right? Going from any framework to this unified bento. And then we have this bentoctl or bentoctl that starts with the bento and it ends with a deployment, right? And in today's demo, I will show you how one can go from a Scikit-learn model. I just went for the simplest model checkpoint there is, right? All the way to a AWS SageMaker deployment, right? So this is what the video is about, but the trick is, right? Even if you are interested in, let's say, transformers, you can just make small changes to what I'm going to show you and it will work, right? That's the power of it. I prepared another sketch about what exactly needs to be done. I mean, there are a couple of steps and a couple of config files you need to kind of work with, but I will go through them one by one. First of all, we want to create this model object. Anyway, let's just start by defining Python packages that we need in the requirements.txt. I actually already defined them. So these are the ones we need. You will see why, but yeah, the two main workhorses are bentoctl, BentoML. So let's install everything in my current virtual environment. And let us now focus on creating a minimal bento model. By the way, the way you kind of work with BentoML is through the command line interface, and there's also, of course, a Python client. But if you just want to check the state of things, you can just use BentoML. We will show some specific examples later on. Anyway, let's create the model. So I did not want to overcomplicate this, and I just decided to go for the iris dataset, right? So let me just show you. Because here the model is not important, right? It's how you get from a saved model checkpoint all the way to the deployment. So we have support vector machine, and we have data sets. Maybe we can swap the order, whatever. Data sets and load iris, I believe. And once we load iris, we just want to turn it into the features and the targets, right? So iris data, I believe that's it, iris target. And And now we create a classifier, which is a support vector svm support vector classifier, a gamma. To be honest, I don't remember what this means. Doesn't matter. And we just fit the model, right? This is where things get interesting, because after like running this line of code, you know that we have a fitted model with weights inside. And what we can do, right, is to just like pickle dump it on the disk. That's how what you would usually do. But now we can kind of just assume that the model is in memory, and we can directly use a helper function from Bento to save it into a BentoML model. So save model, BentoML Scikit-learn, save model. And as you can see here, basically they implemented this namespace for Scikit-learn, but they basically have the same logic for different frameworks, right? And let's call it a iris classifier and insert our classifier instance. And I think that should be it. Let's do this. And so if I do Python create model, and as you can see, it printed out this model instance representation, and now we can actually go back to the command line interface of BentoML, and we can type models and list, right? And I have a bunch of models already, so let me just grab through those that have the string iris in them, and it's exactly the one we saw in the standard output. So actually, you saw how easy it was to create a model, right, out of a Scikit-learn checkpoint. So we have the model now, and our next goal is to create the bento, right? And what is the difference between a model and a bento? Bento not only contains the model, but it also prescribes how you serve the model, right? So there's a RESTful API with some kind of an endpoint where you defined what the request body is of that endpoint and what the response is of that endpoint. Let's try to quickly write the service. So let's do it. So the service is actually going to start with some imports. And by the way, here I'm going to use Pydantic and typing. You need to take the model, or kind of load the model we just created, and turn it into a runner. What's cool in Bento is that they actually separated the running logic, or the inference logic of the machine learning model, and the serving logic. So we create this runner object, BentoML, Scikit-learn, and get iris CLF, and we just use latest. We could use the exact tag, but latest works as well. And we just kind of load it, right? So this entire thing is a model, and this will turn it into a runner object. And now we create a so-called service, which is again basically the abstraction for serving. And here we can name it any way we want, but let's name it iris classifier. Yeah, something like this. Runners, iris, yeah, so we just do iris. Let me actually fix the typo here. Iris CLF runner. And we're basically saying, hey, create a service that is going to depend on these runners, but we have a single runner. And now we're going to define what the request body looks like, and also what the response body looks like. So if I remember correctly, the iris dataset has 4 features, and they are the following. Yeah, I mean, in theory, right, nothing prevents you from just having a request where you accept an array, but I just wanted to make it nicer. now is the time to define response. And the response will be super simple. It will be just a single, let's say, key value pair, and it's going to represent the label we predicted. And by the way, we could be running things in a batch mode, right? Bento actually has amazing features when it comes to like parallelization. They also support adaptive batching, but this is not what the video is about. So there are 3 possible classes. We defined request and response bodies, and now we just define the service itself or the endpoint. It's reminiscent of how, let's say, Flask and Fast API works. So we first need to kind of say, hey, our input, which is the request, is going to be a JSON, and the Pydantic model is going to be our request. And our output is again going to be a JSON, and the Pydantic model is going to be response. And I believe that's all we need in the decorator. And now we just define a classify endpoint. This basically this name of the function will be then transferred to the name of the endpoint. And what it accepts is a request using typing here, and it returns a response. Perfect. And now we just need to define the logic, right? So what we do is that we first of all take all of the 4 features that we kind of sent over nicely in a form of like key value pairs, and we turn it into an array because that's what Scikit-learn expects, right? Request. And now we actually use our runner, right? So at the top we have this runner that we created. It's like a global variable, let's say. And here we just like treat it, it's the Scikit-learn model. And we pass a single sample batch of our input. And the label index will be just a number from 0 to 2, right? We want to actually map it to the actual name. I hope I'm doing the mapping correctly. Again, this model inference doesn't really matter. Stoza, Percy, colon. Now we finally return our response instance, and it's going to look like this. Yeah, so this looks good to me, and this is, as shown here in the sketch, the first part of basically building a bento. But already before even building the bento, we can try to serve this service file, right? So we can do BentoML serve, and we just pointed at the service. Let's see what happens. As you can see, it started a server on port 3000, and voila, we have the classify endpoint. By the way, there are other endpoints which are super useful for monitoring what's going on inside, but I'm not going to talk about them. All right, so as you can see, this is our input schema, right? All of them are mandatory, and yeah, we then get this response. So let's try it out. Let's say I put zeros everywhere, and yeah, the label is Setosa. If I remember correctly, the way the model is supposed to work is that like if you increase these, you should get a different label. I apologize if the model is not correct. Let's actually do the second part, which is defining the bento file. And here we just say service, and we say, hey, the service is going to be from the service file. We don't need to write the .py extension. And inside of it, there's a variable svc, right? I mean, we saw it if I open it here. So if I do service, there's this variable svc, so here we just point at it, right? Then what you need to specify is what to include. So we want to include the file itself. In real life, your bento file would be way more complicated, but I guess you get the idea. And also you can refer to the docs. And now we need to have a Python section where we say that we want inside, or we depend on the following packages. We only depend on Pydantic and Scikit-learn. And finally, the final point here is that we need to define what models we depend on, right? And we saw that it's this one, basically. And here I need to write dash. And I think this should work. Yeah. So now that we have both the service and the bento file, we can use the BentoML build. And by default, if you look at what the help says, by default, it reads or looks at this bentofile.yaml, so we don't need to actually provide anything extra. So let's just do BentoML build. And there's a problem. And here it's models, because you can actually depend on multiple models. Maybe now. And we ended up with this bento, finally, the central data format of what we're talking about today. And you can either, let's say, save it, right, somewhere, or you can again use the command line interface, and you can just do BentoML list. BentoML list is basically a nice way how you can list all your bentos. All right, so we are done with the first part, right? We ran BentoML build, and we have a bento. What you could do now is to just use BentoML containerize, which would build a Docker container, but just a regular one with no, let's say, special build configuration. But in our case, since we want to build a custom Docker container or Docker image for SageMaker, we actually now have to go to bentoctl that kind of supports all of these different deployments. And conceptually, we start with bentoctl init, and it will create 3 files that I will talk about. So yeah, let's start with bentoctl init. You will need to run, if this is the first time you're running it, you will need to do bentoctl operator install AWS SageMaker. And the reason why you need this, yeah, it already exists in my case. So the reason why you need to specifically install this operator or this plugin is that bentoctl does not actually implement the plugins itself. It uses other repos. So if you go to the README, you can see that you choose the platform you want to deploy on, and each of them, let's say, corresponds to a new Git repo. So we are interested in SageMaker, right? And as you can see, there's this AWS SageMaker. Yeah, this is what we just ran. But anyway, let me go back to bentoctl init. Great Iris, so that's how we named it. And yeah, we want to deploy on SageMaker. This again depends on your AWS instances. Let's go for the smallest one. If you had a GPU, let's say compatible model, you definitely want to get a GPU instance, but this is fine for me. Initial number of instances is 1, timeout 60. I don't want to capture any data, and I don't want to provide an S3 URI. And here we'll just keep the default values, no. And under the hood, it generated 2 Terraform files. One of them actually defines the infrastructure, right? And the other one just holds the variables. So let me go inside of every single one of these. So first of all, we have this deployment config that basically stores the result of this initialization, right? What is the operator name, and the region, instance types, and so on and so on. When it comes to the bento variables, these will be actually inserted whenever we do terraform apply and terraform plan and terraform distort. And finally, the main thing is lying here. So the goal of Terraform is to make sure that the infrastructure is captured in source code. Very often people refer to this as infrastructure as code. And I will let you go through this specific Terraform yourself. What I just want to point out is that we kind of assume, since we have a data here, we assume that somebody created a ECR repository. So ECR is a container registry, right? And that there's an image. But then there are a bunch of resources that we define that are relevant to the deployment. And know that it's not as simple if you're familiar with SageMaker, right? There's a bunch of stuff that you need to figure out. You need to, first of all, figure out the roles and the policies, as with every AWS service, but you also need to create a model. Once you have a model, you need to provide an endpoint config, and only then you can create an endpoint. But that's the beauty of bento control. You don't have to worry about this stuff. You don't have to read through this Terraform at all, right? This is taken care of. So these are the three files. What we now want to do, right, is to call bentoctl build, which will, as you can see, actually use our deployment config, and it will also use our bento that we already have, and it will Dockerize it in a way that SageMaker actually wants us to Dockerize things or containerize, and then it will actually push it to ECR. So let's do it. Deployment config, and now we need to specify the bento. I forgot what it was. Let me do list and grab iris. So this is the name of our bento, and let's do bentoctl build -f deployment config, and the bento name is this. And as you can see, now it's building. This will take some time. All right, so we officially built our Docker image, right? And we can see that bento control actually says that it changed the variables. So let's actually see what's new in the Terraform variables. And as you can see, it added two things. This is the tag of the image, right? And this is the repository it is in. And yeah, the version is here. Well, to convince ourselves that this image is actually correctly pushed to ECR, let's use the AWS CLI to kind of inspect. So AWS ECR describe repositories. And as you can see, there's one repository and its name is Great Iris, which is very promising. And if we look at all those images that are inside, AWS ECR list images, repository name is equal to Great Iris. We have one single image in our repository, and that's exactly the one we built. So now we have our Docker image ready that's compatible with SageMaker. Our bento control variables got updated. And now what we want to do, right, is to take the main Terraform file, defining the infrastructure, the variables it depends on, and we just use Terraform from here on. What is going to happen if we do it? So Terraform plan var file. So we need to provide the variable files, ctl variables, and this will just show us the plan. And let me not misspell this. Yeah, actually one thing I did not put in the sketch here is that we need to do Terraform init as well. I will fix it. Cool. And let's now look at the plan. The plan just shows you what resources will be, let's say, created, destroyed, modified, and so on and so on. This is the plan, and of course, now we're ready to apply things. And this should be relatively quick. Anyway, so this took some time, but now we are basically done. As you can see, there are two outputs. One of them is the ECR image tag. We have seen this before. And here we have a public endpoint to which we can send a post request, right? I mean, if you don't like the idea of this being public, you can always like modify the resources, right? I'll leave that up to you. And let me also show you the console. I think it's interesting, right? So I'm already in CloudWatch. What you can do, you can go to SageMaker, right? And in SageMaker, you can go to endpoints. Through here, you can get to the CloudWatch logs, and you basically see what's going on the inside. Now what you need to do, right, is to just send the post requests. But before I do this, let me just serve the local one. So if I do BentoML serve, and let me BentoML list, grab iris. I will just serve our bento locally, right? And we will get the Swagger UI, which is what I'm after here. So serve and point at this one. And let me go to the root. And what I want to do here is to send a request, and Swagger UI will also give me this curl, right? So I can send the same request via curl. And yeah, let me just give it a try. So, and paste it and just send it. And as you can see from the logs, there was a post request, and returned what it's supposed to return. Yeah, of course, label Satosa here. Yeah, perfect. And now the idea is that we use the same request, but we just change the URL to the one that we saw in our Terraform output. And let me modify the previous command. So let me go back here, and here, let me just delete until C. Let's insert it here, and yeah, that's more or less it. So let's run this. And as you can see, we got back the same response. Let's try another thing here. So if I provide 5, 7, 7, or 6, which one are we going to get for Tunica? And just to verify that we were really heading that endpoint, right, we can go to CloudWatch, refresh here, and there were a bunch of GET requests that are just checking the lives, which is like, I guess, SageMaker's way of making sure that the container is okay. Here we had a post request, as you saw, and that's all I wanted to show you. So in my opinion, this is a super simple way how to deploy a model, but I mean, hopefully I managed to convince you. One last thing, if you are tired of this model, if you don't want to pay AWS any more money, you can easily destroy things, right? So as we had the command for apply, I believe, terraform apply, we can do the same thing with destroy. Just be careful, because if you just do destroy through Terraform, it's not going to destroy the ECR repository and the image. And that's why there's this like wrapper that you can use, and it's just bentoctl destroy. Right. And after running this, you will see that you will basically get rid of all the resources. All right, and just to verify that we destroy like the resources, let me use the AWS CLI. So list images. So now it says that the repository doesn't exist even, and ECR describe repositories. As you can see, there is no repository. And I mean, we can do the same thing with the other services, right? So we can say SageMaker. If I do list models, models, there should be nothing. And if I list endpoints, which is the actual deployment, there should be nothing. And yeah, that's it. I hope you enjoyed the video. I hope you found it useful. If you have any questions, feel free to ask in the comments. And yeah, we'll share all the resources on GitHub. Anyway, have a nice rest of the day.